Hi, good evening everyone. Welcome to this webinar on understanding the issues in archaic practices in financial modeling. This is a two-part series. What we're going to do is, in the first part, we will try and understand about what are the issues in the traditional best practices, or what we call as best practices. What is the problem in that? We'll try to understand that. And in the second part, we will try and understand, which is going to be tomorrow, we'll try and understand how the new techniques such as dynamic arrays come into picture. First, let me share my screen with you so that you can understand. I can take you through certain illustrations here. Let me reduce myself in the screen, and here let's take you through the Excel file. First, we are going to understand certain best practice. We are going to start with understanding some historical context in which a lot of best practices have come, and then we'll talk about how things have changed over a period of time. We'll also talk about what are the best practices where we all agree on the same aspects, but we'll also talk about where we disagree with the best practices, where best practices that are followed currently can fail us. Firstly, let's talk about how did Excel became a tool of modeling, or in general spreadsheet. Now spreadsheets were long ago, when they came in, they were designed for end users, right? They were designed for users who did not have strong Excel or computer competency, computer proficiency. It was designed for them. But over a period of time, what has changed is our own competency has increased. So if you think of it, 10 years ago when I was teaching Excel, somebody would say VLOOKUP was advanced. Whereas today when I speak to somebody, they don't even call it as intermediate anymore. They say that they know basic Excel and they understand VLOOKUP. So that's where there's a difference. There's a difference in how we perceived Excel skills versus what it is now. And the biggest problem with the best practices is that they have not caught up with these changes. They have not caught up with the improvement in skills, and this is still focused on end users who have limited understanding. But before I take you through all those things, let's understand certain aspects of Excel. Some of you may already be knowing this, but let me start here. So first we will understand how do we refer to cells in Excel, and here itself we'll understand how things could be different the way we do. So for example, when you're referring to a cell, one way you could refer to a cell is through relative referencing. So when I'm linking to a cell saying that it's D7 or C7 times D7, when I'm giving a function like this, what I'm doing here is using a relative referencing. For me it is C7, but the way Excel interprets it as same row, two columns before. And let me get it in lakhs, and if I'm going to refer it to, let us say I want to divide it by a lakh, I'm going to divide it by C3. A lakh is basically 100,000. And I want the C3 to remain C3, so what I'm going to do? I'm going to use a dollar sign. This is absolute referencing. So this way of referring to cell is something a lot of us understand, right? Now we know how to work with absolute and relative referencing, but do you know you can also work with names? So for example, what I'm going to do is that I'm going to refer to this particular cell or this range of cell, I'm going to name it as, let us say, sales in INR or INR sales. I'm going to refer to this range and I'll type it as, in the name box, I'm going to give it a name INR sales. And exchange rates, I'm going to give it as, I'm going to select them and I'll give it a name as, let's say, FX rate. Now if I wanted to convert this INR sales into USD, I need to divide it. I need to divide it as E7 divided by F11. But one other thing I could have done is I could have given it as INR sales divided by FX rate. If you were using older versions of Excel, you had to give it as an array function, or you could still give it. You will get one cell answer, and with that you can go and copy paste and get answers for other cells as well. In the new version, however, you just press in one cell, you will get answers across all the cells. Of course, this is a feature we're going to be talking about tomorrow in our dynamic array session. but you can refer to a cell even using its name. Now, I want this in millions, not in 100,000 or a lakh. So I need to convert millions into thousands. So what I'm going to do, I'm going to use a conversion unit here. So I have to divide this by 10 if I want it in millions. So a million by 100,000. So I want all of them in millions. So then what I could do is, now I can pretty much divide it by this cell. Again, what I can do, instead of referring to the cell manually, I can as well refer to them using names. Right? I can refer to them through cells, or I can as well refer to them through their names. I could have given a name. And why I'm talking to you about these aspects when we are talking about the best practices and the limitation is, if you look at many of the best practices, they discourage working with names. Why? Because when I look at a cell, I clearly know where the data flows from, but when I look at a name, it is not that clear. What is this FX rate? So from a transparency perspective, some of these best practices do not encourage working with names. But later on, tomorrow especially, we will try and understand why you should use names. But let's also understand other ways of referring to cells. So we said, I can refer it as a relative reference, I can use absolute reference, and I can refer to a cell with names. We can also name cells with, or we can also use what is called as tables. So I'll just show you quickly here with a couple of illustrations. So here what you see is I have a set of data where I'm having a list of dates on which I have purchased various assets and the amount at which I purchased. Now, is this a table? This is a table to human eyes. Now, you can work with, if I want to get sum of purchases, let's say value of total purchase or total purchases. One thing I can do is I can use a summation. Right? I can use a summation here. But another thing that I'm going to do, another way to refer is where you mark that as a table. Now what you see here is a table, and the way I'm going to refer to this is not using a traditional Excel approach where I'm not going to say it is going to be I7 to I15, but I'm referring to this range. It reads as table 1 amount. Now this table, what is the advantage of referring to something as a table? When you refer to something as a table, I'll also soon show it to you with another illustration. But when you refer it as a table, now the machine knows what you've built is a table. Now the advantage here is that if I go to one more data, let's say if I purchase one more asset, let me add it in both the places. Let's say I'm going to buy one more asset. I'll buy another car for $1 million. Now this purchase that I did in my original formula, it has not flown anywhere. But if I create another similar purchase in the next table, you would notice that our summation now automatically factors this in. Our models are much more agile, right? So you can refer to a cell with its cell address, you can refer to them with names, and you can refer to them with tables. In fact, there are some more approaches. We will also talk about that shortly. What I'll do is I'll quickly see if some questions have come. I'll take your questions and then I'll move on. Okay. So far we haven't got many questions. So I'll continue with what I was talking about. Now, why do we need to use tables? I'll show you one more illustration very quickly with a file that I had built. I'm going to load a file, a new file that I have. So I need to load it to your YouTube screen. So yeah, I have it now on the screen. So let's look at this particular file. In this file, if you look at it, let's look at the kind of data I have. See, in one sheet, I have data that says, so-and-so dealer lives in so-and-so or is residing in so-and-so state and city, and what product I sold. Now somewhere else I have another table which says, which classifies the city by tier 1, tier 2, tier 3, which city falls in what category, and one more table that tells you which state comes in which zone. Now in today's session I'm not going to be explaining you how this worked, but in a traditional approach what you would have done, if this was not a machine readable table, if these were just a bunch of cells, if you had to do an analytics where you want to figure out sales by zone, then what you would have had to do is you would have had to use VLOOKUP or any such function to pull out based on the state. You would have had to pull the state zone into this table. Based on the city, you would have had to pull the tier into this table. But if you look at what I have, I don't have any such thing here. But still, if you look at my dashboard, I have a dashboard where I can make the machine read the data and I can make the machine give me filter data by regions. I can clearly say, I want to view sales, let's say in tier 1 cities, or I want to get sales by Delhi. I can pull this data here and I can move it based on the relationship that we have created. How was this possible? This was possible because I have created a relationship, and this relationship was possible to be created because these are marked as a table, and tables are machine readable. Machine understands them to be table. Now with that, I'll close this file. As I said, today our agenda is not to go through this file in detail. So once again, let me just change it. Yeah. So that's what we understood, the role of tables. Now let me come to having introduced you to these new features. There's a lot more new features actually. Now let me come to what is wrong or what is the limitations of traditional approach to financial modeling. See, when you talk about traditional approaches to financial modeling, what is the overwhelming or overriding concern for us? Some of the things that we insist is, one, flexibility. We want our financial models to be flexible so that when I change an input, the output automatically changes and it becomes very easy for me to extend a few years. Now we all agree this is an important best practice. The next thing we insist is that model should be simple and transparent. And what do we mean by simple and transparent? That means the function should be easy for an end user to understand, even if they are not professional financial modelers. They should be able to understand how things work. And this particular best practice is insisted because we want our model to be user friendly. People should be able to easily understand and update. Now what are the limitations here? The limitation is a simple approach and a flexible approach are often at odds with each other. They don't necessarily agree with each other. I'll give you an example. So let us say I have a simple sales data where I have sales, and let's say I've got sales for a few months, January, February, March and April. And I know that this particular sales, let's say we would normally collect our money in 1 month time. So what I have done is that I have linked my April collection to March sales, March collection to February sales, and February collection to January sales. Now this is simple, isn't it? Now for some people this is also flexible. Why? Because if I had let's say May sales has been input and I can simply copy paste my collection data for May, it works. So many a times we think this is flexible because I can easily copy paste and this gives me my new answer for next year, right? So this is absolutely fine. But here is the thing. Who told us that, how do we know that, why did we link to cell E4? In F6, I've linked it to cell E4. Do we know why we linked? You and I know, because I just explained to you as well. Does the machine know why are we linking it to E4? Most often the machine doesn't understand. And why machine doesn't understand? Because we didn't build the logic into it. And what is the limitation here? Let us say my view changes. I think that it's going to, collection will take 2 months time. Now, under the current approach, what I would have to do, if I'm using a very simple approaches, I will have to manually change the links. So the flexibility and simplicity, you can see here, I wanted to keep it simple, but now it was not flexible because when I had to bring in a change in assumption that it's going to take 2 months, I had to manually change the links. So this was not as scalable and as flexible. So I had to do it. Alternatively, what would I recommend? What I would recommend is somewhere you capture this. Let us say I'm going to have collection period. If the collection period is, let's say, 1 month. So what I want to do is I want Excel to apply the logic and apply this 1 month. So here is where I'm going to talk to you about one more way to refer to a cell. One more way to refer to a cell is through directions. When we talk about directions, we talk, for example, one of the things I always tell people is that when you want to ask somebody to come to your home, you can either tell them your address or you can give them a landmark, and from there you can give them directions. So Excel also has a feature like that. So here, for example, I could have given a function here, something like offset from the current cell, go back as many columns as that is there here. And in fact, I'll also do one more thing, because if it's 2 months, I'm just going to copy paste this. I'm going to copy paste this data. And when I copy paste this data, what we notice is that things work absolutely. When I change it to 2 months, we notice that automatically our numbers references changed. So March is now pulling me January data and April is now pulling me February data. Yes, we do have some problem in January, for example. Now I could have fixed it. I could have fixed this with an if error function probably. I could have used the if error function so that if there is a text or some other error, I could handle it. If error will not handle a text, but by multiplying it with 1, I am bringing in the numerical operation. So as we can see here, we can very well handle these things and our file moves absolutely fine, right? Now this formula is not easy. I mean, this is not simple and transparent. And again, transparent for whom? That becomes a problem. This is not simple, but this is extremely flexible, extremely flexible and extremely agile. But with the over focus on simplicity and user friendliness, sometimes the existing practices discourage people from using such complicated formulas. Now they don't explicitly discourage. Let me also make it clear. They don't explicitly discourage. But when you go through these best practices, their overwhelming focus is on keep the formula simple. So you would see a lot of text like this. Keep the formula simple. Rule of thumb. Rule of thumb meaning typically they would say your formula should not exceed the size of the thumb when you place it on your monitor. So these kind of rules that comes into picture and that forces people to keep your formula simple. Now I would say that's fine. I pretty much agree with those formulas or agree with those rules, but they cannot be my overwhelming concern. My concern should be about the integrity of the model, not simplicity of the model. So these are some of the things that goes wrong. And I'm also going to take you through a few more examples that would just tell you the limitations in our approach to financial modeling, where even something that looks extremely well built, something that looks very professional can also have these limitations. But before I move on, let me again quickly go and check if I have received any questions. Okay. Okay, one of the questions is when I clicked on Delhi, why didn't the Excel file change? I think there is some, it's set to manual mode. I think I will probably have to change the formula mode there to automatic. That is probably the reason why it didn't change. Now again, let me come to one more illustration. Why sometimes, and in fact this is the biggest risk I would say. The biggest risk is where a model looks professionally built, they look extremely good and they carry certain risks. So let's look at this particular model. I downloaded it from a third-party source. It's not my model. This looks fairly well built, and if you look at it, it has a lot of functionalities. So what do we have here? I have at discounted cash flow valuation models. And the way this model works is it looks at cash flows, it calculates cash flows, and we are going to do a discounting for as many years as we want to hold the shares, and we are going to assume that we will exit the share on a particular year. So we are perhaps expecting to exit this company in 2024. Let me freeze the page so that we also see what is happening. Now this is what we have done. We have assumed that we will exit the company in 2024 or 5 years from today. We will hold the shares for 4 years, and at the end of 4th year we would exit the company. And based on this, we have calculated valuation. We have used a LPV function to do a valuation. Again, as I said, it's not my model, I pulled out from somebody. Now this looks professionally built, and that is actually the area where risk comes in, because when it's professionally built, we assume that it works absolutely fine. What is the challenge here? What could happen is, let's say these models are kept and maintained for next several years, right? We use the same model and we use it for next several years. For a moment, let's assume that I plan to hold it for next 4 years. Now, who is here going to decide once the next year comes, 2021 comes, this terminal cash flow should not be applied in 2024 because one more year has come. So if I'm going to hold it for 4 years and sell, I need to put this formula in 2025. And my cash flows will have to change. And my functions will have to change. I have to actually modify all these things. I have to literally modify these things so that I can now say what's happening. If I don't, and again, I am facing some error. When I try to extend it, I'm finding some error. I didn't build it, so I really don't know the source of error. Now, here is where the risk happens. What can happen is an end user, when you build a model and give it to them, an end user may not understand that they have to do it. And even if they understand that they have to do it, sometimes what happens is, I'm working and I'm in a hurry. My boss is behind me. I forgot to alter this. That becomes a problem. And one more thing is, even from a flexibility perspective, think of it. As an end user, wouldn't we sometimes want to know, let's say I'm an investor, I plan to hold this company for 3 years or 4 years and sell it. Wouldn't I want to know, if I held it for 1 more year, if I held it for 5 years or 6 years, what would then happen, right? We have the forecast. But we really don't know what would happen. Now, since our concern was simplicity, what ended up happening is we have an overly simplistic model that fails when people want to, let's say, change the timeline. My date of exit I want to change. Now, this doesn't really tell us what would happen if the date of exit changes, because those fail proofings have not been done. And if that fail proofing had been done, things would have been great. But why we didn't do it? Because that would have made the model complicated. It would have breached the condition of simplicity. That's probably what this was not done, right? So how would I suggest that we do it? One of the things that we could have done is, for example, use a query structure. So maybe one thing I can do, or even some more things here. So for example, I could have done one thing where I could have said, I would have captured certain things. I would have captured my year of exit, let us say, where I'm going to give the end user the flexibility to do this, right? And then I could have done this as equals EBITDA for the given year times the multiple, which is 5x. Now that's getting linked to KF54. So let me retain that. So I'm going to do this equals EBITDA times F54. And I would want to add a condition saying that this should be taken only if, let me do it from here. So F54 is where they have the multiple called 5 times my EBITDA. But I need this if and only if the year equals, let's say, 2024. This perhaps sometimes it makes your model a little complicated, no doubt. But essentially what is going to happen is this would ensure the F54 should have also been fixed. So this would have ensured that I get 5 times of my number here. One second. Because this was not my model, that was the problem. Oh, I should have used year function because that's a date there. So I would have probably put a slightly complicated function. And I would have fixed this, and I would have not just fixed it here, I would have fixed it all the way through. And one more thing I could have done here is in each of these things, I would have said this total cash flow is something you should take if and only if your values here is less than or equal to my 2024. Again, year of H7. So these functions when I bring in, they make your model complicated, but that doesn't mean this is how the model, that doesn't mean you should not build the model this way, because this model now is fairly agile for me. When I work, I could have as well done something else where I could have extended this all the way through. Now all that end user would have to do is they would have to just change the end year. If they want to consider selling it to 2025, they would have just had to change it. And once they change, everything happens, right? Sometimes I may even want to use a query structure. I may want to use a query structure like a lookup function and pull the data. So these things can help us make our model much more robust. And I'm going to just give you one more example here. I'll give you one more example, and this is going to be slightly time taking, so we'll probably take 10 to 15 minutes on this example. This example is something where I'm going to spend some extra time also taking you through step by step how the, because we are now entering into the, so far what I talked to you about was limitations of traditional approaches which focuses too much on simplicity, not on agility. But now I'm going to go in and talk to you about the data model approach, which is a relatively new approach. This approach has been possible for over 12-15 years right now, at least ever since Office 2007 came. The latest from Office 2010. It has been possible, but it's not widely adopted. So let's see how it works, and let's talk about certain limitations. So before that, let me quickly take some questions. Yeah, so let me see if there are some questions. Okay, so one question is, I have a couple of questions here in fact. So will it be possible for me to create a financial model for a public company from adding historicals from financials to all the schedules, etc.? Not sure if I got the question clearly here. Is it about, or are you talking about whether we would do this in this particular webinar? See, the idea of this particular webinar is not to focus on how to build a model from scratch. The idea of this webinar is talking about the best practices and how you could use data modeling approach. Tomorrow, when we talk about dynamic array approach, we will be doing that tomorrow. When we talk about how to use tables and dynamic arrays, we will take some historical data and I'll be showing you a small model, not a full-fledged model, but a small model and how to build that using tables and dynamic arrays. That's something we'll do tomorrow. Next question is, should I use R1C1? I mean, what is my view on R1C1 style reference? Should we use it? Any benefits? I really discourage R1C1. I even discourage A1, A2. As we will see in the next example, I discourage using even cell referencing using A1 and B1. We would like to work with tables and range names rather than working with relative referencing. Now, this is one of the biggest area where I depart, or not just I, a lot of us who are trying to come up with new standards, we are trying to depart from this traditional approach because, as I told you, these are designed, be it R1C1 style, be it the relative referencing A1, B1 style, they are all designed for end users with limited computing skills. It was also relevant even 20 years ago when I was building models. I had a 16 MB RAM and 133 MHz processor. With that, there are certain calculations like offset or a VLOOKUP I could not have used them. But today, our systems are much more stronger, our competency levels are much higher. So here is a time where we need to leave this hypothetical end user who does not understand much of Excel and who wants to work with cell references. Today we are dealing with far more advanced users, and I'm going to take you through some approaches to that, right? So firstly, let me give you this example. What I have here, I'm somewhat simplifying things because mainly I'm by assuming constant interest rate, I've made things slightly simplistic. Let's look at what do I have here. I have a loan table, and in this loan table I have four different loans, A, B, C and D, and these four loans are of different amounts. To keep it simple for today, I'm assuming they all carry same interest rate and they have certain tenures, and through a PMT function we have calculated installments, and we have last year. Now you would see most financial models built even by professional firms, how would they look? So if I have four loans, you have four separate schedules, right? You have four separate schedules where you have opening balance, interest, you're going to take opening balance into interest rate, repayments and closing balance. You build one schedule for loan A, one for loan B, one for loan C and another one for loan D. You build separate models for each one of them, then you summarize them. Now this is generally expressed as a best practice because this is transparent. I know what's happening to each individual loan, right? If somebody were to ask me what is the loan B, how much loan B would be outstanding in 2022, I have the data. The calculations are easy to understand, and within each loan we can easily copy paste. So if you look at those who are supporting transparency and simplicity, they would definitely say this is a good model to do. And I have seen a lot of models built by several consulting firms, research firms and other professional services firms. This is the standard that they follow. Now what is the limitation here? Let us say if I were to bring in one more data. For a moment, let me assume that these loans were all borrowed in 2020. These loans were all borrowed in 2020, that's the last year. And let us say I'm bringing one more year into picture, which is one more loan which I'm going to borrow in 2021 or 2022. So I'm going to borrow a loan E, which is going to be borrowed in 2021, and this is going to be for whatever number, let's say 1500. Now what is going to happen? These formulas should have changed. I should have changed it earlier. Now what is going to happen is, now that I have added loan E, I need to create a separate schedule for loan E. Just like I did for loan B, I need to create a separate schedule. It's not very complicated. I can just do it by inserting because we have followed certain best practices. So I can do this, right? So I'm just going to change the cell reference everywhere. And I've got the answer here, right? 2021, 25, I've built it. But problem is this. Now then what I have to do? I have to go to my total and I have to alter this. I've added just extra loan and I have to make sure that I link this extra loan to my total. This is how I have to work. Now where all can things go wrong? What did I do? I copied this, pasted it here. It happened very fast. I mean relatively fast, 2 minutes. I changed the cell reference, didn't take much time, right? I know if loan D was cell 7, then this should be cell 8. I took care of that. But I had to change it, right? It was easy, but still I had to do it. And in my total, I still have to link it. I now had to link loan E. So there were 3 things that I had to do manually. In fact, if I have to do it step by step, so that's 1, copy this whole block, change the heading, change the cell reference, 3, 4, and then add the link. And I should add the link and then copy paste it. I had to do it for everything. So there were around 10 actions that I carried out, but it didn't take much time. So a lot of people are happy with this approach. They say, you know what, this is working fine. This is simple, this is flexible. But here is the thing. I could have made mistake in any of these cases. It's easy, no doubt, but I could have made mistake in any of this. I probably forgot to change the cell, let's say for repayment. So my repayment is still linked to G7. Or I changed that, but I forgot to link it in my opening balance. In any one place, if I had made a mistake, my model would have gone for a toss. And this is what actually happens in real life. Most of the time when we build model, we take all the pains to ensure that it works correctly at that junction. What we don't factor in is about future changes. We assume that, because this is easy to do, we assume that the end user would do it. Now, but here is the problem. I'm working for 16 hours a day. Sometimes, this is my 16th hour, I'm exhausted, and my boss is behind me. They want this updated file very soon. I could have made this mistake at any point in time, right? One of the thing could have easily gone for a toss. And the worst part is, these mistakes sometimes will remain undetected. They'll remain undetected for ages because it's a very small mistake. Let's say I forgot to link the interest amount to my P&L account. So my interest was understated for 1 year. Maybe it's not a very big interest amount at the end of the day, 346 out of total 2189. So someone missed it, and because they missed it, things could have been, we may not see it for a long time. And when will this blow up? It will blow up much later. And here is where we're going to use data model approach. What's a data model approach? In this data model approach, what I'm going to do is, let me bring in that same start here, year of loan. So I have it in this place. (2020). So what do we mean by data model approach? In a data model approach, I am not going to rely on cells. I'm not going to go to C1 or D1. We are going to define everything by fields and records. So what we are going to do first is we are going to make this into a table. As I told you, this is a table for human eye. This is not a table for machines. And let's make it machine friendly. I'll go to insert. Let me make it as a table. Now this is a table. By going to insert and clicking on table, this has now become a table. For machine, this is a table. I'll also give this a name. I'll call this as, let's say, death schedule or something, DBT-SCH. So I'll select the table, go to my table design tab. I'm going to call it as DBT-SCH. This is fine. So what do we do now? How do I handle this? So what I'm going to do is, I am not going to refer to, I may still use the cell reference to a certain extent. Let me size these columns so that they all have consistent columns. So what I'm going to do is that I am going to get my opening balance, interest and everything using query structures, but these are not SQL queries, these are Excel driven queries. Maybe here I would use a sum ifs. So for example, right now I am here, so I am going to take this amount borrowed. If I had borrowed the amount prior to current year, or for now opening balance, let me leave it. Let me have something like, I'm just slightly worried that I would be going into for the opening balance, let me have it. I'll keep it a little simple. Interest, since I'm assuming the interest rate to be same, I'll in fact keep the interest elsewhere. Let me assume interest rate to be same for now. You can also handle it when it's not same, except the mathematics gets a little complicated, nothing else. So for now, let me not have a separate line for interest. So I'm going to assume that the interest rate is constant for all the loans. For now, as I told you, this can be handled as well, but the mathematics gets slightly complicated, and which I don't want to overwhelm you today. So what are we going to do? My interest is going to be opening balance times the interest rate. How do I get the repayment? So what I'm going to do for the repayment, in fact, let me also add one more line because I'm going to borrow one more. So I'm going to have one single schedule here in which I'm going to factor in everything. So we'll deal with the borrowing a little later. So I'm going to give a repayment here where I'm going to say, the amount I repay would be equal to sum ifs. All these amounts will be repaid provided two conditions are satisfied. What is it? The last year of loan should be less than or equal to current year. Greater than or equal to current year. The last year should not be in the past. So this is one condition. And the first year of loan should have been in the past, which means this should be less than or equal to current year. So I'm going to assume that this is going to be less than or equal to current year, and closing balance is going to be sum of all these things, and my opening balance is going to be this. Right, so if I've taken the loan last year, I'll be paying it. And what do I do about amount borrowed? What I want to say is, if I take an amount borrowed, if that amount is reflecting in the year of loan is current year, it should come in amount borrowed. So I'm going to use that one as well, equals sum ifs, I want amount borrowed provided the year of loan is current year. Once I have this, let me just copy and paste this across. You can clearly see 2027 our loan is going 0, right? 2027 is our last year and we are paying 362, our loan is going 0. And if I had to add one more loan, loan E, let's say I'm going to borrow this next year, 2021 is where I'm going to take the loan, and I'm going to take 1500 for 5 years tenure. You notice that our model is automatically flowing fine now, because automatically the 1500 has come into the picture. Perhaps I should have taken interest on the opening balance as well, because we are assuming that the loan is borrowed in the beginning of the year. So I should have applied interest on this one as well. And once we apply, you would notice that things automatically flow. We don't really have to do anything about this. Let me just see, something is not right here. This should not have gone to. If I was earning 2021 and 1500. Okay, I think something is, its repayment should be capturing the full section and loan. Okay. I'll just check what I mean, there is no reason for it to give us a wrong answer. Okay, I'll have to, but essentially, this can work. This can work when you add it automatically. I probably am making a small mistake here, but this formula can automatically factor this in, and this can give us a robust schedule automatically, right? So I actually have a model built using dynamic array. Let me just quickly show you. This is something we will be discussing tomorrow. So when you're working with dynamic arrays, one more thing that can happen is, it cannot, in fact, in here I'm even working with different interest rates. The best part about dynamic array is, it not just updates the columns here. So here I have a very similar thing that I have built out. Opening balance, amount borrowed, repaid, interest rate, using the SUMIFS function. Of course, I've used a slightly more complicated mathematics here because the interest rates are changing. But in this approach, what you notice is, if I add one more year and one more loan, if I added 5% of, capex as a percentage of loan is, let's say 5%, and I'm going to borrow 50% of my capex as loan, this is going to be taken at interest rate of 6%. And the moment I put my final input, let's say this loan is for 5 years, the moment I put that, you notice that it also automatically expands a couple of columns. So through this data model approach, what we can do is, we can ensure that our model automatically updates itself as more and more new loans get added. So this is the advantage of working with dynamic array based models. or rather data-based approach. And this can ensure, sometimes what people end up worrying is, for now let me not have this loan E. So sometimes what people worry is, okay, you built a scalable model, one model automatically captures everything. But what if I wanted to just view, let's say, loan A? I wanted to know the balance of loan E, or I wanted to view the balance of loan B. What do I do? Very simple. What I suggest in those cases, give them a separate tool for it. Give them a separate utility for this, where what we're going to do is this. In addition to what we just did above, I'm going to add one more filter here. I'm going to add one more filter where I'm going to say, enter the loan name. Loan A or B, C, whatever loan you want to enter it here. And what I'm going to do is, in everywhere, I am going to bring in this criteria. I'm going to say, I want debt amount, provided the loan that you're looking at is this loan. Right? So this is the loan I'm looking at. The interest rate is going to be borrowing here. I'm again going to add one more condition. The amount borrowed should come into picture provided the loan we are looking at is this loan, C11. So you're going to add an extra utility to your own file. Interest again into interest rate, that's not a problem. Repayment, again add one more. Everything is same. I'm just going to add one more condition that the loan should be equal to loan A. Closing balance is fine. So let me now copy and paste this. So if you want to understand what is happening, I want to say, let's say I want loan A, and let me even do one more thing. I'll also give a data validation tool here. I'll create a list, and I'm going to say that this list should have a source from here. So let the end user choose whatever loan they want. So on the top, you have something that gives you the total, and at the bottom, I can choose whatever loan I want, and I get to see what is outstanding. This will also, so it satisfies both your needs. What it satisfies is, I want a scalable solution that can factor in whenever new loan gets added. As I saw here, there is some issue probably in the way I've linked. That's why this was not going to 0. My concern was, why wasn't it going to 0? It should have gone to 0. Maybe somewhere I made a mistake. And that's again to say, as an end user, you can make a mistake no matter how much years of experience you have. Sometimes when you're in a hurry or you're in a pressure situation, you can make a mistake. And when you make a mistake like that, when we are building here, I knew there was a mistake, and probably I could spend time on auditing and trying to figure out what went wrong. But later on, if you did not, we don't build a scalable solution, then what would happen is, later on when we are maintaining it, doing routine upgrades, we may not be able to take so much time out all over again to audit mistakes. And that's going to be the problem. And that's one of the reasons why I insist that we use data model approaches. In fact, now that I've built this utility, it's easy for me to figure out where loan E, when I entered loan E, what went wrong. Let me just quickly check that. So in 2021, I said I wanted 1,500 for 5 years. Let me go to loan E. Okay, so here is where things are going for a toss. Our opening balance, we didn't apply a filter there. So in opening balance, I should have applied a filter that the date of borrowing, I had given some amount, but what I should have put here is perhaps the date of borrowing should be before the current year. So I realized that this was a problem. So I could have put one more condition here, sum ifs. This is the amount, and I want to take it only if the year is before current year, because the future loans should not be coming into my opening balance. So opening, now that we factored that, we have a schedule that works absolutely fine. So I'll have the same thing here as well. Sum ifs, the year of borrowing should be before the current year. Right. Yeah, there is still a problem because we are assuming that the loans are paid at the beginning of next year. So that part I did not fix. Yeah. So the loans are paid at the beginning of next year, then you would also save interest on the loan you borrowed, and that will ensure that things go to zero. Okay, I mean, I'll have to fix some assumption change here. One more, I'll have to fix this. But essentially what you can do is, as you can see here, once these things are fixed, we'll be able to have a model that automatically updates on its own, and you can also give them these extra utilities where what you can do is you can very well show them that if they want to see, I want transparency, you can do it. But where does this one go foul with the existing best practices? Now these formulas are not rule of thumb. My repayment here is pretty big. It's not a rule of thumb, and it's not very simple. It's not very transparent. So these are the areas where sometimes people would say, this is too big. But at the end of the day, this kind of an approach is what helps us to have strong models. And what we need in modeling is not simplicity as much as integrity. Our model should work under all situations. It cannot fail under any circumstance. Right now, this model that I built had some small issues because what happened is the way I gave the formula, there's a inconsistency. I'm assuming loan E is repaid at the beginning of next year, whereas loan A, C and D are all paid at the end of this year. There is a small inconsistency with regarding to that. I'll probably fix it very quickly here with one small fix. So I'm just going to have to do this. Or fair enough. This is something we'll be discussing in the next one, because right now this is obviously a silly issue that we have done, but this can actually, some silly mistake, but this can actually take too much time to fix if you have to fix it. So that's something we can discuss tomorrow as we get into this. What I'll do is I've got quite a few questions here. I'll also take these questions and perhaps we will end the session right after this. So the questions here are in terms of, will this video be available? Yes, this video is going to be available. So there is no repayment period for opening balance. Yeah, so you're right, that opening balance we did not fix that, so that has been fixed. Since I don't see any other questions, what I'll do is I wanted to keep last 5-10 minutes for questions. So I'll wait for a few seconds for questions. Otherwise, we'll wrap up our video here. And alright then, thank you very much. Hope to see you tomorrow, where we'll discuss more about dynamic arrays and how this entire thing can be taken to the completely next level in financial modeling.